This is Josh White with JW Math Tutoring. In this video, I'm going to cover Digital SAT Linear Paper Test number 9, the Math section modules 1 and 2, specifically the unique questions that do not appear on any of the Bluebook practice tests. So let's go ahead and get started.
But life is a dream the calculus could never predict.
Just before I get started going through these questions from Digital SAT Linear Non-Adaptive Paper Practice Test number 9, Math section, a couple things to keep in mind. First, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, I've said this at the start of all the other linear test unique questions videos. Okay, these are the questions from, like I said, linear paper test number 9 that do not appear in any of the Bluebook practice tests. So I call these unique questions. So in other words, doing these questions, going through these questions will not affect, anything with regards to any Bluebook practice test because these questions are not found in them. Okay. Most of the questions on these paper practice tests, the linear paper practice tests, do overlap with Bluebook, but not all of them do. And so these ones I'm going over are the ones that do not. All right. And of course, there's a link to a PDF file where you can download all the unique questions. This file currently has 7 through 10, practice test 7 through 10 in it. Or, of course, you can also just download the full linear paper practice test from the College Board's website as well. There's a link in the description for that as well. All right. So that being said, let's go ahead and get started on these. Okay, first question, you just have a very basic linear equation, and notice that they're asking what 16x is equal to. So all we have to do is just subtract 30 over here, and we just get 16x equals 160. So the correct answer for this is C. Now, I will mention, wouldn't necessarily recommend this, but you can, of course, if you want, just go to Desmos, type this. Oh, x is 10, but we need 16 times 10. 160, and get our answer that way. Okay, so again, I think it's for this problem it's always slower, but whatever, you can do it that way if you want. All right, next up, question number 10. These, by the way, we're starting in module 1, of course, and then we'll do module 2 after that. Here we have just a basic formula with y and p and x, and it wants to express this in terms of y. Express y in terms of p and x. So all you have to do for this, it's literally one step. We're just adding 57 to both sides, and that's it. Y equals px plus 57. The correct answer for this one is B. Again, you could technically do this one in Desmos because it's a formula problem, but I would not recommend that because it's literally just one step and whatever. I'll save that for more advanced or more complicated problems, or check out my Desmos guide for solving formulas using Desmos as well. All right, next up, number 13, we have a system of linear equations. So this one is set up such that you can do substitution right away, meaning you can plug this in for y. And then 3x plus negative 2x, well, that's just 1x, and we get 40. So the correct answer for this is 40. Now, maybe you instead want to go and just do it in Desmos instead of solving it by hand, which is perfectly fine. So if you do that, we graph them out. Now, where do they intersect? Looks like it's right over here. X is going to equal 40. So we get the same answer, either way. All right, next up we have number 22. Here we have a function, polynomial function, technically a cubic function. And then we have another function, which is basically this original function shifted. Everything's shifted 1 unit to the right because of the -1 inside here. Okay, so this new function, g of x, has intercepts at a, b, and c, comma 0. Basically, what's the value of a plus b plus c? So the intercepts for the original, or for f of x, are going to be -6, -5, and -1. Okay, this x minus 1 in here, x minus 1 inside the parentheses, is equivalent to a shift to the right of 1 unit. So that means you add 1 to each of these, and you get -5, -4, and 0 as your new x-intercepts. So maybe this is A, maybe this is B, maybe this is C. Add them together, what do we get? -9. Correct answer for this one is letter B. Now, you could also, of course, do this problem very easily in Desmos. So let's graph our original function. Then let's graph our translated function. Okay, so now we have our translated function. So what are the three x-intercepts? That's our a, b, and c values. Well, -5, -4, and 0. And now you're just adding these three x values, -5 plus -4 plus 0, and that's how we get -9. All right, next up, question 27. This is the last question in module 1 of linear paper test number 9. We have two rectangular prisms, i.e. basically a box. One is larger and one is smaller. We know that the surface area of x, okay, so the surface area of x is 58. What else do we know? The surface area of y is 1450. And we know the volume of y. Okay, volume, actually I'll put it down here where the y is. We know the volume of y is 1250. Get rid of this. Okay. We want to know what is the sum of the volumes for both prisms. So basically that means we need to find the volume of prism X and then just whatever that is, add that to 1250 to get our answer. Okay, so here's the whole entire key to this problem. The ratio of the surface areas, which is 1450 over 58, okay? If you divide those, you get 25. That is what's known as the area factor. Then you square root that. You square root the area factor, and that's what's equal to the scale factor. The scale factor is how many times larger is the side of one prism compared to the other. So square root of 25 is just 5. Therefore, the scale factor is 5. So in other words, each side in prism Y, which is the larger one, is 5 times the length of its corresponding side in prism X. That's what the scale factor is telling us. Now, here's the other thing that you need to know. The volume factor, which relates the volume of two basically similar 3D objects, prisms in this case, is just the cube of the scale factor. So in other words, the volume factor is equal to the scale factor cubed. So you take 5 and you cube it, and that gives you 125. That means the volume of the larger one, which is y, is equal to 125 times the volume of the small one. So in other words, the volume of x times 125, the volume factor, is equal to the volume of the larger one, basically the volume of y. So then you just divide basically by 125 and you get the volume of x just to be 10. So what's the combined volume of both prisms? Well, 10 plus 1250 is just 1260. This is the correct answer. This is the answer that you would type in the answer blank. All right, so let's go ahead now and start the unique questions from, again, so linear paper test 9 module number 2. First one, very basic equation, just subtract 7 from both sides and get w equals 350. Of course, you could go to Desmos, you could type this equation in Desmos, but you'd have to scroll out a bunch to look for the vertical line at w equals 350. Or actually, no, you couldn't do that. You would have to change it. Actually, this is something good to highlight. Even though this is a really basic question, I will still highlight this. First, so if you try to type with w, nothing would happen. You have to switch it to x. All right, and then we have to zoom out. Okay, there's the thing, 350. However, if you wanted to use w, what you would do is you would just solve it using regression like this. And right there it says w is 350. Okay, so if you want to use a letter other than x or y, letter other than those, then you just use a regression statement and get the answer that way. All right, next up, basic distribution property. 16 times x, 16x. 16 times 15, it's going to be 240. Correct answer is going to be letter B. Now, of course, you could go to Desmos and you could type the original expression, and then you could type each of the answer choices and see which ones are equivalent as well. Probably longer for a basic problem like this, but it is still an acceptable method. All right, next up, question number 7. So here it's just basic. Here, this is just basic function evaluation. They just want to know what's the y value when x is 3/11. So you're literally just plugging in 3/11 for x, adding it to 8/11ths. If you add the two fractions, that's 11/11ths, which is just 1. Correct answer for this is just 1. That's it. Now, of course, you could go to Desmos if you're having issues with the fractions, and you just easily type in the function itself, x plus 8/11, and then f of 3/11ths. Then you get your answer there, +1, and that's it. All right, next up, question number 11. Here you have an exponential function that they're modeling, and basically wants to know, I'll tell you right here, exponential relationship. Basically want to know which of these is the correct function, that matches this situation. So if you're familiar with exponential functions in general, it's basically, the basic form I like to use is like a out front, and then 1 plus or minus r, and then to the t. R is your growth rate. In this case, it would be interest rate, but it's like growth rate, or it could be decay rate if it's 1 minus r. But A is your initial or starting amount. So in this case, the initial or starting amount is 604. Therefore, the correct answer must have 604 in front of it. So by process of elimination, it has to be C. But if you didn't know that, if you weren't that familiar with exponential functions, here's how you could still get the correct answer in Desmos. We're basically just going to back solve this by plugging in a point from the table. So what I mean by that is I'm going to do the first function, and I'm going to pick the 1 60642, meaning I'm letting t equal 1. And actually what I'm going to do is I'm just going to, yeah. So notice here, do I get 60642 for answer choice A? I do not. So that is not correct. That is wrong. All right. Now for the next one, 004. Okay, that's obviously it's nowhere near 606, so that's wrong. Now for answer choice C, 604, 1 plus 0.004 to the t. Okay, notice here I get 606.416. It's not exact. It's not the exact same number you see, but that's because of rounding. So they round it to the nearest cent, and you would see that, yes, this would then match. And you also see that this is going to be the closest one as well, because when I plug this in for D, again, it's not 606.42, nowhere close to that. So that's how you could solve this in Desmos alternately, by, again, taking one of the points, plugging in the values and seeing, plug in the t value and seeing, do you get the same dollar amount, as your output. All right, question number 18. Here you have a polynomial, technically quadratic, and I'm basically just asked to interpret, like, essentially m of 330. It says approximately equal to, so whatever, we'll use like this, 362. Okay, so 330 then would be plugged in for t, because t is what's inside the parentheses here. It's m of t, so that means t equals 330. So that means we're looking for an answer that has what's the unit here? T days. Okay, so we're looking for an answer which has 330 days in it. So answer choice A, 362 days. Nope. Answer choice B, 330 days. Keep it. Answer choice C, 330 over 7 days. Nope. Answer choice D, 362 days. No. So by process of elimination, it has to be letter B, and that is the correct answer. And then also just to confirm, the output here, the 362, like, i.e., would you plug the time in for days, and then you work this all out and whatever. It says here predicted body mass. So 362 right here is a mass. You're looking for kilograms, and looking at answer choice B, we can see right here 362 kilograms. All right. Next up, question number 21. Here you have a version of an exponential function, and they tell you a point that it goes through, 0, negative 25. They also tell you a second point it goes through, 223. What's the value of a plus b? First, I'll show you how to do this by hand. Then I will show you how to do this in Desmos. So you're going to do this by hand. What I'm going to do is I'm going to start with the first point and plug it in. So negative 25 equals a to the 0 plus b. So a to the 0 is just 1, and that means b has to equal negative 26. All right, so we already have one of the numbers. Now we can take the second point and we can plug that in, 23 goes in for f of x or y, a to the second, a squared, plus b, which is minus 26. Now we can solve this for a. 49 equals a squared. A equals square root it. Notice it tells us a is positive or greater than 0. That means it's only going to be positive 7. We can ignore the negative 7. So a plus b equals 7 plus negative 26. The correct answer is negative 19. Now, let's learn how to do this problem entirely in Desmos. So all we have to do is make a table. Put in our 2 points. Now, the problem is if you click this button and do add regression and then choose exponential from the dropdown, it's not going to be the same form that they give you in the problem. So that's why I'm going to just type it in manually instead. All right, right here, a positive 7, b negative 26. So what is a plus b? Negative 19, boom. There's our answer. Again, this took me all of about 30 seconds to do in Desmos, and that's how you can do the entire problem. All right, next up, we have question number 26. This is in my mind, just a particularly annoying question because of all the different letters and constants and conditions on the problem and so on. So the easiest way that I think to solve this or to visualize this is to do picking numbers. So I'm just going to go to Desmos. I'm going to do the entire problem basically using picking numbers. So let me just show you a couple things first. If you notice here in this first one, okay, notice that k is equivalent to this thing right here. So I'm just going to make a note, k is equal to 2.2 to the b. Also notice in the second one here, like if you distributed this, it would be a times 2.2 to the x plus a times 2.2 to the b. So this whole thing is what matches with m. So in other words, m is equal to a times 2.2 to the b. All right, we'll come back to that in a second. All right, let me just see. Get this on the screen here. Clear this out. All right, so I'm going to graph my original function. Need another parenthesis. Nope. Okay. So I graphed the original function. Now I'm going to add some sliders. The values that I chose here were 2 for A and 3 for B, and that meets the conditions of the problem because they are both positive, they are both integers, and A is less than B, i.e. B is greater than A. All right. So now that that's done, okay, the equation. Which of the following displays the y-coordinate of the y-intercept? Okay, so I go here. What's the y-intercept of this graph? Okay, it's 23.296. So we can either like keep that, you can write it down here. What I'll do is I'll just export it. And so we have it right there. Okay, this is the thing that we want to, let's move this up. This is the value we're looking for in both g and x. Okay, so now what I'm going to do is I'm going to graph g of x. The x, okay, and then, oh, actually no, I need the extra parentheses. And then for k, let me just make sure this is correct. Okay, so what I did is, yes, okay. So what I do is I'm going to put a k in here, just so it matches perfectly, right? And now k is equal to 2.2 to the b. All right, so this is the number that k is equal to. So now looking at g of x here, do we see the number 22.296 anywhere in this function in this equation? Okay, the answer is no. We have this a out here, a is 2. We have k is 10.648. So we do not see 23.296 anywhere. So the answer for number 1 is no. Okay, so we can get rid of this, we can get rid of this. It's now either 2 or nothing. Now for the second one, h of x, a 2.2 to the x, and then plus m. But again, I'm going to define m. I already said m is equal to a times 2.2 to the b. Okay, so now looking at h of x, do I see the number 23.296 anywhere in the problem as a constant or coefficient? And the answer is no. Again, a right here is 2. And m, the 2.2 is obviously not the same as that. And then m right here is 21.296. That is not the same as 23.296. The decimal parts match, but obviously it's not the same number. So therefore, for 2, it's going to be a no as well. So the correct answer for this one is going to be letter D. All right, so I hope you enjoyed the solutions to the unique questions from, again, linear, non-adaptive paper practice test number 9, math section, both modules 1 and 2. If you have any questions or comments, please do leave them below. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. As always, check out the other videos, which feature the unique questions from the various linear paper practice tests. Basically, I'm working on 7 through 10 first, and then I'll be going back to the older ones after that. And also, just as a reminder, if you're looking to improve your knowledge of Desmos for the SAT math section, please check out my Ultimate Desmos Guide to Digital SAT Math. It's over 3.5 hours of tips and tricks, instruction, and 45 practice problems to help you master Desmos.